With that, we are ready to now welcome our next speaker, Azfar Sajid, who will be talking to us about quality gates in DevOps Pipeline. So Azfar is QA Modernization Manager at Lumen. He is an experienced senior technical professional with 20 plus years of proven capabilities, working in many diverse and challenging environments. He has the breadth and depth of expertise in Agile Safe, DevOps, DevSecOps, web and client server, quality assurance, automated test design and analysis, and testing practices and methodologies. So with that introduction, we see Azfar is on screen. It's over to you, Azfar.
Thank you, Trishma, for good morning, good afternoon, and good evening. I am joining this session from Colorado, Denver, Colorado. It is 4 a.m. in the morning, so if I slip a little, please forgive me. Hoping and praying you and your families and loved ones are all safe and protected during these unprecedented times. First of all, I want to thank the organizers of SLASSCOM Quality and Business Summit 2021 for giving me the opportunity to present today. My topic today is quality gates in DevOps Pipeline. But before I dive into the presentation, let me briefly tell you about myself. I've been in quality assurance, as Trishma just mentioned, most of my professional life. That is about 20 plus years. For the past 4 years, I've been managing a team of engineers who specialize in DevOps, DevSecOps, functional automation, and performance engineering. Automation is my passion. Last year, we all went through a lot, adapted to new ways of working and collaborating. It gave us time to reflect and do soul searching. I've become a firm believer in doubt kills more dreams than failure ever will. So believe in yourself because you can. So let's dive into our topic. Before I start, I just want to give a quick overview of a typical DevOps pipeline. You may be aware of, or you may already be working in a DevOps pipeline, but I just want to quickly give a quick overview. In your development environment, you could be using a tool like Jira for planning. Your development could be in Java or .NET. You could be using a version control or source control product like GitHub. Maybe using Jenkins for continuous integration, use Gradle or Maven for build, and then for quality testing, maybe employing SonarQube, XUnit, JUnit. For functional testing, for UI testing, you could be using some products. You could be doing API testing, headless testing, and then using some standardized methods. You may be deploying the code to Kubernetes, your cloud, or it could be in production, and finally running some monitoring tools and logging tools using tools like Zabbix or Elk. So this is a typical DevOps pipeline, and our focus today is how does quality testing fits into the DevOps pipeline. I simply love this graphic as it accurately depicts a traditional way of testing. In order to make a revolutionary change or transformation, we have to move from an ice cream cone-shaped testing to a more effective way of testing using this automation pyramid. So my mantra here is automate, automate, automate. Automate the unit test, which is the foundation, automate the component test, automate the integration test, automate API test, and automate your customer journey or end-to-end test. As a servant leader, the question that gets thrown back at me is, we have finite hours in a day. We do not have time So when do we automate? Well, my hard and realistic answer is be effective. Do time management and prioritize your activities. Invest in yourself to become a more technical person so you are an Uber tester. So let's dive into a little into this software testing pyramid that I touched on earlier. What are some of the key challenges in adopting the pyramid approach? Traditional software testing, software development focuses a lot on coding features. More time is focused on development rather than quality. That is burning the midnight oil to get the feature out on time. Some common feedback: manual efforts for integration and testing are too slow. User interface driven testing is too slow and fragile and does not efficiently provide good testing coverage. So how do we get over this conundrum? Some recommendations: combine coding and testing into a single activity. Stop the waterfall approach in Agile methodology, where first part of a sprint or an iteration is used for coding and later for testing. Both QA and development need to go hand in hand, provide quick feedback by having continuous integration and automated testing. Structure the test suite using the test automation pyramid. As you can see here, the foundation is your unit testing. You have to have the most number of test cases here, and these are the fastest. And as you go to the top of this software pyramid, you can see how unit testing is then followed by component, followed by acceptance testing. So as you go up, you have fewer test cases, but the focus is starting with unit testing. So I'm hoping that this view is giving you an insight into how do we shift left. So this is a big buzzword nowadays in DevOps, like how do we shift left in our testing. So instead of focusing a lot of time towards the tail end, we are partnering up with our development counterparts on how we can be in lockstep in testing with them. So how test automation fits into the DevOps pipeline. So in the previous pyramid, I kind of touched on this, but let me go over this once more. So at the bottom, I talked about unit test, or it can be test-driven development. The tools that you use, JUnit or XUnit, some characteristics, the common properties of a unit test: small scope, done by the programmer and or the QA practitioner, and are fast. On top of it, we go with sanity or build verification test. These are small UI or API tests that go beyond just simply pinging the application under test whether it's up or not. Followed by this, we have inter-system testing, or it is also referred to as integration testing. The reality is your application interfaces with many applications upstreams or downstreams, and you could be testing across multiple domains. For example, you could have a quoting domain, an ordering domain, a provisioning domain, activation domain, billing domain, and the list goes on. So you start testing at a component level or at an atomic level, but then it should encompass inter-system or inter-application or integration testing. The next phase is solution testing, or it is sometimes referred to as end-to-end or a complete customer journey. Just imagine if we do our due diligence in integration testing, it will automatically pave the way for a very smooth user acceptance testing. The last phase is user acceptance, where there needs to be a very tight integration or synergies between UAT and end-to-end or solution testing. As I mentioned earlier, integration builds upon functional testing and end-to-end testing builds upon integration testing. So if we do our due diligence from the very foundation and work ourselves up, finally, it is the production. We deploy the code, and I know because of certain regulations, system testers cannot test in production. So how can we still help with production validation? Well, if we have a good suite of automated test cases built, and as long as those test cases are not updating or changing your real customer data, we should be able to use them in production. So I'm hoping, again, I'm able to convey this message of shift left and how we are able to reuse our component level testing and build on top of it to include sanity, build verification, integration, and customer journey. So now you would be wondering, how does all this fits into a DevOps pipeline? Well, that is the crux of my presentation today. How do we have quality gates and DevOps pipeline integration? In your DevOps pipeline, quality gate number 1 starts with a pull request, or it's sometimes referred to as a PR. So you do a pull request from the source code repository. It is locally developed code, cannot be merged. Your locally developed code cannot be merged with the master branch unless quality gate 1 is satisfied. Quality gate 1, or the foundation, is on a local development environment. The developer and tester needs to build partnership in writing unit tests, use static code analysis using a tool like SonarQube, use code coverage tool like Jacoco for Java, add security tests to expose any security vulnerabilities, also include API or a sanity level test, and the final thing is establish thresholds or passing criteria. That is very important, because if you don't have thresholds, you can easily move from gate 1 to gate 2 to subsequent gates. So when I talk about establishing thresholds, there are some examples, like you have to have 100% unit test coverage, or there cannot be any high security vulnerabilities. So these thresholds can be customized, and it depends upon your environment, how strict, or in other words, little lenient you want to be in establishing these thresholds. Quality gate number 2, this is where code is deployed from the dev environment to a QA environment. It is usually an integrated environment where upstream and downstream applications are available. If your sanity or BVT test fails during the deployment, the code is rolled back. After successful deployment, execute your functional and regression test cases. Just like gate number 1, establish thresholds for passing this gate. So I talk about functional and regression test cases. So here we have kind of built upon our unit test, which is more at the code level. And now I could be talking about, let's say, if you have a UI built, you can now bring in some test automation tools to start building some UI level automation. Or you can still use tools like SonarQube, or SOAP UI, or SOA test, if you have APIs to build automation for your headless testing. From gate number 2, we move on to gate number 3. This gate is where you start your intersystem or integration testing. As I mentioned earlier, this is where you are not just testing within your one domain, but you may be testing across multiple domains. For example, how the information flows from your quoting domain into ordering to provisioning, etc. So it all depends upon what your software development lifecycle is. So you do not proceed to the end-to-end phase unless integration tests pass successfully. Just like your previous gates, we established certain thresholds that would then either allow you to move down the pipeline, or it will be gating. Gate number 4, this is where the focus is on a typical customer journey. So when I talk about customer journey, this is how an end user is going to use your application or your business application. So it is very important that before we bring in a business to give a final thumbs up or thumbs down as part of user acceptance testing, we do our due diligence in integrated environment in testing our complete customer flow. Now, if this phase would pass successfully, you are guaranteed that the UAT will have an easier time. I don't know about you, but where I am, there are tons of challenges between customer journey and getting UAT final approval, because there could be some misunderstanding. There could be, again, testers not working with UAT to understand how a typical customer journey looks like. So how I mentioned earlier, for QA practitioner to be aligned with or in lockstep with development early on, similarly, the tester needs to be in lockstep with UAT or user acceptance testing. So the final gate is your user acceptance testing, or gate number 5. This is where the UAT gives a thumbs up before the code is ready to be deployed to production. So hopefully you can see how we are approaching the shift left mindset and incorporating quality at every step of this pipeline. This approach will definitely accelerate quality beyond the new normal. Everyone owns quality in this pipeline. It is not just a tester's job. So I want to again give some quality gate characteristics. The first is build validation. The gate acceptance should be automated. So since we're talking about DevOps, and I've talked about automating anything and everything during this pipeline, the ultimate goal needs to be your gate acceptance criteria for all these gates are automated. The reason for that is it will minimize any manual intervention. Of course, there will be some times where you have to step in and do manual validation. But our goal needs to be, for each of these gates, the acceptance criteria needs to be automated. So gate number 1, again, is your build validation. You focus on unit testing, security testing. The owner is development and QA. You use tools like JUnit, XUnit, SonarQube, Jacoco for Java code coverage, Coverlet. So these are some examples. And as I mentioned before, you need to establish thresholds. Similarly, gate number 2, this is your deployment validation, where you're going from your local development environment to an integrated environment. Again, your acceptance criteria should be automated. The type of test you bring in are your sanity, build verification test, functional or regression. Again, the owner is development and QA. So you use tools that allow you to build automated UI and API tests. Again, establish thresholds. Gate number 3, application integration. So this is where we build upon our functional test and start doing our inter-system or inter-application testing. I have identified owner as QA, but what I would say as a QA practitioner, we have to flex. We have to work with development and we have to work with business so that there is no misunderstanding and we are doing or testing the right thing. Gate number 4 is your, again, end-to-end validation. Gate acceptance criteria is automated. Type is here you build your solution or end-to-end journey, and you can also bring in some load and performance, because even though you, again, depending upon your environment, you may be doing some initial load testing upfront, but this is where most of the functionality is available and stable, hopefully, and you can also bring in some load and performance testing. And finally, your gate number 5, this is your acceptance validation done by the business. It is the UAT level testing. It could be automated or manual. And finally, if all these gates pass successfully, you deploy to production. Here are some smart or specific and measurable quality gate metrics. So as we are moving through our pipeline, there is always going to be asked to provide some metrics to show progress or to show how good we are doing with the quality of our code. So here are some examples that I have implemented within my quality gates and provide metrics on these. These metrics are your code coverage, that is your percentage of code covered by unit test, your static code analysis, code quality and security, defects opened and resolved. Essentially, it works towards your technical debt from defects, because a lot of times what happens if you log low priority or severity defects, a lot of times they get overlooked and you just keep on building technical debt. Defects by test phase. So sometimes your test phase may be happening in parallel, but if we think about it, we start, as I had said, you could be in unit test phase, you could be in integration phase, you could be in functional phase. So the whole goal is, the earlier on we can identify more defects, the better quality it would be at the time of deployment. Being able to categorize defects by root cause, defects status by priority, deferred defects. These are the defects based on, in discussion with business, the known defects which you'll be sending to production. Leaked defects. So these are the defects which are caught in production because of, again, not having proper coverage. Somehow you missed covering for those scenarios in your testing. Your test execution pass-fail criteria, defect density, and your build pass-fail rate. So these are some of the ways that you can provide metrics by incorporating these quality gates within your pipeline. So in conclusion, I would again emphasize, establish the 5 quality gates within your DevOps pipeline, build And these gates are your build validation, your deployment validation, application integration, customer journey, and user acceptance. To be successful, follow the test automation pyramid, allow shift-left testing strategy, combine coding and testing into a single activity, a closer partnership between development and QA, and drive transformation towards test-driven development. Thank you for your time today. Really appreciate it.
And thank you, Mr. Azfar, for your time and sharing with us your expertise. I see we don't have any questions lined up, but since you have shared your contact details, perhaps our participants will get in touch with you directly. So on that note, thank you very much for joining us, 4 a.m. your time, all the way from Denver, Colorado, and enlightening all of us here in Sri Lanka.
Thank you very much. Really appreciate it.